Hello, geometry students. Well, congratulations are in order. We are officially doing our last notes for the school year for math. So I am so proud of you for hanging in there and being so diligent about watching the notes and working so hard in class, and I'm super proud of you. So thank you for being here. I'm excited to share this last lesson with you. So we are finishing off chapter 11, our last chapter, and the topic is surface area and volume of spheres. So we're going to do the formula for surface area, and then we'll do 3 examples, and then we're going to do the formula for volume and do 3 examples for that, and then you should be totally good to go. All right, so the formula for the surface area of a sphere is 4 pi r squared. So let's do example 1, and we're going to draw our sphere. By the way, as I'm sure you probably know, but a sphere is basically a round ball, like a basketball or an orange or a golf ball or something like that. Now, in terms of the parts of the sphere, the most important thing to know, obviously, is that we have our radius. So this is our radius. And then the other thing that you should know is that if we cut the sphere in half, the circle that we would see when we cut it in half is called the great circle. And the radius of the great circle and the radius of the sphere are the same. So let's say, for example, that this radius here is 8. So I've got a sphere with a radius of 8. If I want to find what the surface area is, I would take 4 times pi times 8 squared. Now, it's important to remember that when we use this kind of a problem, we need to do PEMDAS. So we're going to do our exponents first. So this is going to be 4 times pi times 64. And then I would take 64 times 4 to get 256. And usually in this kind of a case, I would just leave it with a pi on there. So 256 pi. If we're talking about feet, for example, that might be feet squared. If you do want to turn it into a decimal, just make sure to use the pi button on your calculator. That would be approximately 804.2 feet squared if we turn it into a decimal. So that's a fairly straightforward where you have, the sphere, and you just literally plug in the radius to find the surface area. So let's call that example 1. Now let's look at example 2, and we have to be a little bit careful about this. In example 2, what we're going to do is try to find the surface area of a hemisphere. Now, a hemisphere means half of a sphere. So the thing that we have to think about, and let's make this problem even trickier. Let's go ahead and label the diameter, not the radius here. The thing that's kind of tricky about this is you have to consider the fact that if you cut the sphere in half, you're going to have half of the surface area that you normally would. So you're going to have half the surface area of a sphere, but you're also going to have the, and let me use a different color here, maybe a light green. You're also going to have the area of the great circle here that you would need to add to that. So you can't just take the regular surface area formula and cut it in half. So we need to take the half the surface area of the sphere and add it to the area of the great circle. So let's go ahead and do that. If I take half of the formula for surface area of a sphere, that would be half of 4 pi r squared. The area of the great circle would be pi r squared. Half of 4 is 2, so this is 2 pi r squared plus 1 more pi r squared. That ends up being 3 pi r squared. So it's a little bit counterintuitive, but the formula for the surface area of a hemisphere is 3 pi r squared. So I would write the surface area here is 3 pi r squared. Now, in this case, if my diameter is 32, the radius would be 16. So I would need to take 3 times pi times 16 squared. When I square 16, I would get 256, so 3 times pi times 256. Then I would take 256 times 3 and get 768 pi. And again, this would be, say, in feet squared. If I want to turn that into a decimal using the pi button on my calculator, I can. And then it would be approximately 2,412.7 feet cubed, squared. I usually just leave the pi on there because that's the way it is on your SAT exam. Okay, let's do the last example for surface area, and then we'll move on to volume. So the third example for surface area says, find the radius of a sphere with a surface area of 256 pi square meters. So let's write down our formula. Surface area is 4 pi r squared. In this case, they're telling us the surface area is 256 pi, and they're wanting us to solve for r. So the most efficient way to do this is to use opposite operations. The opposite of multiplying by 4 pi is dividing by 4 pi. So I want to divide both sides by 4 pi. I can cross off the 4 and the pi here, so now I just have r squared. This pi cancels out there. Then when I take 256 divided by 4, I get 64, and I would square root each side and get that the radius was 8. So if this was, say, in meters or whatever, I would just say 8 meters, 8 centimeters, 8 feet, whatever your unit of measurement is. So that is how you deal with the surface area of a sphere. Now, I'm going to erase this information, and we're going to talk about volume of a sphere. And then we will be done with new material for this school year. So I'm super excited for you guys. All right, let's go ahead and look at the formula for volume. So we'll draw our sphere here. We'll show the radius. And our formula for volume is 4/3 times pi r cubed. So for our first example, let's say that the radius here is 4. So I'm going to take 4/3 times pi times 4 cubed, or 4/3 times pi times 64. Now, one way I can do this is think of the 64 as being over 1. So I would take 4 times 64 on the top, and I would get 256. I would have 3 times 1 on the bottom. Now on your SAT exam, they're going to leave the answer that way, 256 over 3 pi. If I want, I can see how many times 3 goes into 256. So I would divide it by 3. It grows in 85 times. 3 times 85 is 255. So we could also write this if we wanted this way. Now, if I take 256 divided by 3 and then multiply it by pi, I could also write this as about 268.1, and let's just call this, say, feet cubed. So that is basically how you would go about doing the volume of a sphere. Now, let's do an example where we're working backwards. So in this problem, it says, find the volume of a sphere if the circumference of the great circle is 4 pi inches. So we want to say, what is the volume? And we're going to say the circumference of the great circle is 4 pi. Let's go ahead and draw a picture to go with this. I know if I'm looking at the circumference of the great circle, the formula for circumference is 2 pi r. And I have been told that the circumference of the great circle is 4 pi. So let's put that in for C. And then I want to do the same thing I did on a problem just a minute ago. Do my opposite operations. When I do that, I can see that r is 2. So my radius ends up being 2. Now what I can do is go ahead and use my formula for volume and plug in 2 for r. So remember, I do want to follow PEMDAS and cube my 2 first. And then 8 times 4 is 32. So personally, I would just leave that as 32 over 3 pi. Let's say this is in inches. That would be inches cubed. If I want to turn it into a decimal by multiplying it by pi on my calculator, I would get about 33.5 inches cubed. Okay, we're almost done. We have one more example left. Good job, you guys. All right, this one says, find the volume of a sphere with a surface area of 144 pi square feet. So this is going to take a little bit more work. So it says that the surface area is 144 pi. In this particular example, in order to find the volume, I am going to have to understand surface area. I know that surface area is 4 pi r squared. So I'm going to put 144 pi in for surface area. And then I want to solve for r. So I'm going to divide both sides by 4 pi. When I do, the pi's and the 4's cancel out. This pi cancels out here. And then I have 144 divided by 4, which is 36. When I take the square root now, I can see that r is 6. So I actually had to do a fair amount of work just to figure out what the radius is. However, now that I know the radius is 6, I can plug that into my formula for volume. So I'm going to have 4/3 pi times 6 cubed. And then 6 cubed is 216. If I want to take 4 times 216, multiplying across the top, that gives me 864 over 3 pi. The good news is I believe, yep, 864 can be divided by 3. So this becomes 288 pi. If I want to, and again, if this is in feet, I would say, for instance, feet cubed. If I want to take that 288 times pi using the pi button on my calculator, I'm going to get or approximately equal to 904.8 feet cubed. Congratulations, guys. You did it. I am so proud of you. See you in class. Bye.